Today, we're exploring a truly mind-bending mathematical framework. We're going to look at a singular, foundational way of viewing the universe that actually unites everything. And I mean everything, from the self-driving car navigating your neighborhood, to the massive language models generating code, all the way down to the biological wetware inside your own head. I'm absolutely thrilled to share this with you. Because honestly, once you see this underlying system, it completely changes how you view technology and human behavior forever.
So, think about it. What do ChatGPT, a self-driving car, and your brain actually have in common? I mean, at first glance, they seem completely unrelated, right? One's a software engine processing text, another is a multi-ton machine navigating physical space, and the last is this squishy, organic network of neurons. But what if I told you that they all operate on the exact same underlying mathematical logic? Seriously, they are all just systems trying to make sense of a wildly uncertain world.
Okay, let's dive straight into our roadmap for this. 1. We'll cover the 6 variables modeling the world. 2. Math tools for optimization. 3. Generative AI's thinking process. 4. Physical AI's reality control. 5. The human brain-like machines. And finally, 6. Humans' error, also known as endogenous noise. Starting with Section 1. 6 variables modeling the world.
Here's the secret. Every single system, whether you're analyzing complex engineering, global economics, or even biology, can be broken down into 6 fundamental components. First up, we have states, or XT. This is the hidden, absolute, true reality. So for a robot, it's its actual true location. For the economy, it's the real underlying growth rate. But here's the catch. We can almost never see states directly. And that's exactly why we have measurements, YT or ZT. These are the imperfect, kind of noisy signals we get from sensors or reported data. Now, to change a state, we use policies or actions, like literally pressing the gas pedal on a car, or a central bank changing interest rates. The system itself is governed by parameters. Think of these as the physical mass of an object, or the specific weights inside an AI neural network. And because literally nothing in this world is certain, everything exists within distributions, representing probability. Finally, we have errors or noises, the inevitable random fluctuations and sensor limits that just muddy our view of reality.
Moving on to Section 2. Math tools for optimization.
Now, what's really interesting here is how we can neatly group all these intimidating formulas into 2 primary buckets: tools for predicting and tools for controlling. For estimation and prediction, we use things like the Kalman filter to strip the noise right out of our measurements, or Bayesian inference to constantly update our beliefs whenever new data rolls in. Then, once we have a solid, educated guess at reality, we shift gears to optimization and control. That's where we use equations like Newton-Raphson to find the most efficient path, or the Bellman equation to map out long-term dynamic planning. Every smart system out there uses a combination of these 2 exact columns.
A super quick but vital point on that estimation piece: reality is rarely a simple straight line, right? Therefore, modern physical AI doesn't just use standard linear math. The extended and incented Kalman filters, EKF and UKF, have become the absolute gold standard for dealing with a messy, non-linear world. If a self-driving car needs to turn a sharp corner while accelerating, these non-linear filters are exactly what keep it from completely losing track of reality.
All right, Section 3, Generative AI's thinking process.
So how does an LLM actually think? Well, it follows a very strict mathematical pipeline. Step 1. It maps our messy, complicated natural language into pure mathematical vectors, basically turning words into measurable variables in a geometric space. Step 2, it optimizes billions of parameters. Using our math tools, specifically gradient descent, it fine-tunes its internal weights to minimize error. Step 3, when you ask it a question, it relies on probability distributions to sample the maximum likelihood of the next word. It is absolutely crucial to understand here that generative AI isn't learning strict logical causality. Nope. It's learning incredibly dense, contextual statistical correlations. It looks at the current state of your sentence and simply predicts the highest probability path forward.
Let's look at Section 4, Physical AI's reality control. And this brilliantly illustrates the divide. Generative AI mostly works offline. It trains on a massive data set of the past to predict sequences. Physical AI, however, like a drone trying to dodge a tree in the woods, doesn't have that luxury. It requires a clear physical objective function, like, not crashing. It must use real-time online reinforcement learning.
It's constantly pulling in live sensor measurements, using those nonlinear Kalman filters we just talked about to estimate its true state, and relying on dynamic control tools, like those Bellman equations, to optimize its actions on the fly in a rapidly changing physical environment.
Which brings us to Section 5, the human brain like machines.
Let's move to how this builds into something much closer to home. Through millions of years of evolution, your brain has built prior parameters. It's an inherent structural expectation of how gravity works, how light behaves, basically how to survive. Your 5 senses, those are exactly what we call measurements in the mathematical model. Right now, literally as you watch this explainer, your brain is acting as a biological Kalman filter. It is taking noisy measurements through your eyes and ears, applying Bayesian inference to update your understanding of reality, and minimizing prediction errors to optimize your next action. You, my friend, are a biological machine running the exact same foundational equations as the AI.
Section 6. Human's error. Endogenous noise.
So the crucial point is, what sets us apart? It comes down to something called endogenous noise. See, when an engineer programs a drone, they really only have to worry about external noise, like a sudden gust of wind, or internal sensor noise. The machine's objective function is pure, it's unwavering. But human decision-making, it's corrupted from the inside. Our behavior is injected with endogenous noise caused by our emotional fickleness, our cognitive biases, our shifting moods. Actually, scratch that. It's more like we might completely know the mathematically optimal path, but we choose a totally different one just because we're angry or scared or simply bored. In this mathematical framework, that is a completely different kind of noise that machines just do not possess.
Now, in fields like physics and engineering, scientists can basically completely ignore this human noise. But if you look at modern economics and social sciences, the inability to capture this unpredictable variable is exactly why predicting the stock market or major social trends is so ridiculously difficult. The absolute holy grail of behavioral economics and macro modeling is finding a way to mathematically formalize this human fickleness. If we can somehow fold our psychological expectations and our emotional endogenous noise into those exact same dynamic equations we've been talking about, our ability to understand and predict human society will undergo a massive, unprecedented revolution.
Which leaves us with this final, truly provocative thought. We've seen how just 6 variables and a handful of equations perfectly connect text generators, robots, and our very own brains. The math works. The only missing link in the chain is fully quantifying human emotion and unpredictability. So if we eventually manage to mathematically model human fickleness as just another standard variable in the equation, how perfectly could we predict the future of our society? Does true free will even exist, or are we all just waiting for a slightly better algorithm to calculate our next move? Think about that next time you change your mind for no apparent reason. Thank you so much for joining me for this explainer, and keep questioning the math behind the curtain.